So today we're going to take a quick break from the actual chapter 6 and go into some basic arithmetic with some variables. And we'll spend a little bit of time on this before we move on to chapter 6. So I call this mid-chapter 6, and this is going to be the first day. So what we're going to talk about today is how do you multiply, divide, and raise a number to a power when we use variables. So for example 1, let's just talk about what x squared really means. What does it mean? X squared literally means that you have x times another x. I'm just writing it out as to what it means. Just like if you had something like 5 squared, you know that hopefully you know that's 25, but it means 5 times 5. They mean the same thing. So what you have here is you have 2 of them, and so instead of writing it out like that, we put a little 2 in the exponent here. And you can keep doing this. If we have x to the third power, that means we have 1, 2, 3 x's being multiplied together. And it's just much easier to write that as one term, x to the third power. And we can do it again. You can keep going with this. X to the fourth power means we have 1, 2, 3, 4. So it is much easier, especially at this point, instead of writing it out like that, to just say it's x to the fourth power. We have 4 of them being multiplied together. So let's try to simplify some of these and figure out how we would do that. So if we have x squared times x, and if you don't see a power on here, that just means that there's a 1 there. So we have x squared times x. So that would mean, if I write this one out like up above, that means we would do, I'm going to write it underneath actually, x times x, because that's what x squared is, right? Those two things means x squared, times another x. So x times x is x squared, and then we also have an extra one over here. So that means what do we have now? There's 1, 2, 3 of them. So it looks very similar to this example up here, number 2. So that's the same thing as saying x to the third. And so that's what happens here. X squared times x is actually x to the third. I just wrote it out to show the work down below. So let's go over to number 2. If we have x squared times another x squared, what does that actually mean? That means we have an x times x here. And on this one, we also have another x times x. And in between them, we have multiplication. So now this one looks very similar to number 3 up here. There are 4 of them being multiplied together. So this is x to the fourth power. You can count them, 1, 2, 3, 4. All right, so we can do any kind of combination like that, but hopefully you catch on to the fact of what's kind of going on. Is there a shortcut where we could just look at these two and get the answer? I'll do the long way one more time. So we have y to the third. That means we have 1, 2, 3 being multiplied together, times y to the fourth would mean we have 1, 2, 3, 4. And how many do we have total? 1, 2, 3, 4, 5, 6, 7. So this must mean the answer is y to the 7th power. So we catch what's going on? Instead of writing this out every single time, hopefully you realize that we don't have to do this part. We can just look at the exponents that are there and add them together. Put a little plus between them. 2 plus 2 is 4. 3 plus 4 is 7. And 2 plus 1 is 3. So that's like the first property that you learn when you multiply exponents or multiplying variables together. You can just add the exponents. So actually, I'm going to go down here and unveil this part here. When multiplying variables, you just add the exponents. So for example, if we have g to the a times g to the b for number 4, that literally means we could do g to the, we would take the number of a and add it to b. So the property is a plus b. We don't know what these numbers are because they don't give them to us, but we could write it like this. The whole entire thing is the exponent. How about number 5? Oh, now we have some numbers out here. So let me show you how we deal with this. First, the numbers themselves, 2 and 4, we can multiply them together. So let's just do that part. 2 times 4 is 8. But We do not multiply the exponents here. Remember, when you're multiplying variables, you just add the exponents. So this would mean we would do 3 plus 10. So this would be w to the 13th power. And that would be your answer. So how about number 6? We have x to the 5th and z to the 5th. So does this just become xz to the 10th? Oh, no. We actually are not able to add the exponents here because they must have the same base. I'm going to add that down here. Must have the same base. And by base, I mean it has to be the same variable. X and X or Z and Z. So this actually does not work, and this is the answer. X to the 5th times Z to the 5th does not change. That's all you can do. So you need to memorize these properties. They come up quite a lot, especially in the next couple chapters. So when we're multiplying variables, you add the exponents. So in between here, we have some huddles. You can go ahead and take time to do the huddles, and then I'm going to go back and do some more properties. So that was the first property, and you have 4 huddles to do with that. Next example. So how would this be different if we would divide the variables? So now instead of multiplying them together, like before we had x squared times x, what if we change this to division? Let's see how that works. So I'm going to apply the property we did at the very beginning, where I can say, okay, x squared is the same thing as x times x. The bottom is just x because there's only one of them. And so what happens here is you could look at this and say, okay, well, one of these x's up here will cancel with one of the ones at the bottom. And then what's that leave us with? There's one x on top, nothing on the bottom except for, I guess you could say it's 1, or it's just x. All right, well, let's apply that again. What if we have x to the 3rd? That means we have 1, 2, 3 being multiplied together all over x. Again, we could cancel one of these out, so we can cancel this one out with this one down here. And that means we have x times x, so there's 2 left, so we have x squared. The bottom, there's nothing there. You can write over 1, or you can just keep it x squared. So what are we doing here? How could we just jump from this question to the final answer? Can you figure that part out? What we're doing is we're basically just, instead of adding the exponents, now we are going to subtract. So if I put a little 1 on these exponents here, or these variables, what would you do here? It would be 2 minus 1 gives you 1. And then you don't have the division anymore, no more fraction. This one you would do 3 minus 1 is 2. So you don't have to write this out every time, but you should kind of know where it comes from. So now we can apply it. So let's unveil the ones down here. So when you're dividing variables, as long as they have the same base, I'll add that again. Same base. What do? We just subtract the exponents. So you start with the top variable. So you take the top number minus the bottom. So let's try it with some numbers in there as well. So what do you do with those numbers? Don't worry about the numbers. You can just do the variables like you usually do. So we can do 3 minus 2. So that means there's 1 left, right? So then you write your answer on top. So it's y to the 1st. There's no more on the bottom. So 2 of them will cancel out with 3 of them. If you want to write that out, you could see it. It's 1, 2, 3 on top. There's 2 on the bottom. So you would have 1 cancel out with 1. Another one cancel out with another 1. So you'd have 1 left. There it is. Then once you're done with that, then we have to do actual division with the numbers. So we do 20 divided by 4. You don't subtract here. It's not 16. 20 divided by 4 is 5. And so it looks like we have nothing again underneath the fraction bar here. So we don't actually have a fraction anymore. It's just 5y. If you want to put the 1 power, that's fine too. You don't have to. All right, number 4. 15 and 7. So we're going to do subtraction again. So to do this, we do 15 minus 7. And what is that? 8. So that will be our power on our x's. So let's do that. We have 15 minus 7 is 8, so it's x to the 8th power. And then here we have negative 18 divided by 6. So we actually divide these numbers. Negative 18 divided by 6 is negative 3. So when you divide, it stays on top. If you had it on the bottom, it would be a fraction, right? When you divide these numbers, you don't get 1/3, you get 3. So again, there's nothing left on the bottom. That stuff goes away, and we just get negative 3x to the 8th. And that's your answer. Make sure you take some time and know how to do these things, because it gets much more complicated when we put all these things together at once. Again, another team huddle for you to do. There's 5 problems. Make sure you try those. I think we only have like 2 more properties left. Yeah, and then we're done. So example 4. How are we going to simplify variables if there is an exponent? So what if we have x squared, and then it's being raised to the 3rd power? So let's write this one out so it makes a little bit more sense. So what does that mean? So we have 3 x squareds. That's what that means. So we would have x squared times another x squared times another x squared. And you could keep going. You could write this as x times x, x times x. You could keep doing that multiple times. However, we already know the property here. Whenever you have the same base, you just add the exponents. So let's put little pluses here. We just add these together. 2 plus 2 is 4, plus 2 more is 6. So this total answer would be x to the 6th. So maybe you can think of how this happened. How can we go from the original to the final answer when you have a 3 and a 2 here? I'm going to try it again with this one here, simplify it. Now I have a number inside there. That's okay. What does this mean with the 2 there? That means you have 2 of these being multiplied together. So we're going to write them out. We have 1, 6x to the 5th, times another one, 6x to the 5th. So that's not too bad. We've done ones like this before. We do 6 times 6. That gives you 36. And then we're going to do 5 and 5. We can add them together because they're exponents. So it's x to the 10th. Hopefully that makes sense. We're going to try quite a few more. So I'm going to do another one the long way, and then we'll go down and reveal the sentence down below. So if you have 2x squared to the 3rd power, that means we have 3 2x squareds. So you would write it out 3 times. 2x squared. Times 2x squared times one more, because you got 3 total. So again, just do the numbers one at a time, and then we'll do the exponents. So 2 times 2 is 4, times another 2 is 8. 2 times 2 times 2 is 8. And then with the exponents, we add exponents because there's multiplication between them. So 2 plus 2 plus 2 is 6, x to the 6th. Okay, let's jump down and do... we'll do 2. So this means you have 3 of them. 5g to the 3rd times another 5g to the 3rd times one more 5g to the 3rd, because the outside number was 3. Again, do the same thing. You have 5 times 5, which is 25. 25 times 5 is 125. And then g to the 3rd, g to the 3rd, g to the 3rd, you add them together. 1, 2, 3. So 3 plus 3 plus 3. That would be 9. Okay, so what is actually going on here? How can we do this without writing this out every single time? If you look at this in here, we have g to the 3rd and g to the 3rd, or to the 3rd here. 3 and 3, if you actually multiply them, you would get 9. So with the variables you multiply, 3 times 3 get 9. Where's the 125 come from? How does that work? Well, that's kind of the same idea. You have 5 to the 1st. So what you do is you do 1 times 3, and that gives you 5 to the 3rd. And 5 to the 3rd is 125. So this might be kind of difficult because there's some numbers in here, but Let's maybe try one with without numbers in it. Let's jump to 5. So we have k to the 10th raised to the 10th power. So when you have a variable with a power in here, we're going to multiply these together. So it just turns into k to the 10 times 10 is 100. So if you don't know this trick on how to do this, then you would be stuck writing this out 10 times. So the answer here, when taking a power to a power is what we call it. You have a power going to another power. What do you do with the exponents? You just multiply them. So maybe let's just practice doing that with the variables. So if I go to 3, y to the 5th raised to the 3rd, we're going to multiply these two together. So our y value in the power would be 5 times 3. That's 15. What you do here is 3 to the 3rd power because you have a 1 on the 3. So it would be 1 times 3 is 3. So this is 3 to the 3rd. Oh, boy. There we go. And that's something you can put in the calculator, or you can just multiply it out yourself. 3 to the 3rd is 27. So that's your final answer, 27y to the 15th. Number 4. Again, we'll just do the variables. There's only one variable here, but we have x to the 4th being raised to the 2nd. So between these two, you multiply them together. So we have x to the 8th. And then here we have 4 to the 1st, which would be 1 times 2, or 4 to the 2nd. Some people just like to think that you just take the 2 and you just put it on top of the 4 as an exponent. You can do that too. So what is 4 squared? That would be 16. X to the 8th, and that's your final answer. All right, we have one more. Again, with the variable, exponent to exponent, we multiply them together. 11 times 3 is 33. And then 3 is also going to be raised to the 3rd power. So it's kind of in a sense like distributive property where it goes to both of them. So this would be 3 to the 3rd power. Please be careful. It is not 3 times 3 because 3 is a base. It is not a power itself. The power on 3 is actually 1. So be very careful with that. So 3 times 3 would give you 9, but that's not this answer here. This is 3 cubed, which we had earlier. This is going to be 27x to the 33rd power. That's your answer. But we're going to do a lot of practice with this, so if it's still kind of hazy right now, don't worry, we're going to do some more with it. There's a huddle that goes with this, 1 through 7. And we have one more set to do. And the rest of it is for you to finish. So the last part we're going to talk about is what if you have negative exponents and what happens there. So let's talk about simplifying negative exponents. In general, if you have x to the negative, let's just say 5. What you can do with this to make it positive is you put it as a fraction, put it over 1, and then you actually flip these two things, and once you do that, the exponent turns into a positive. So it would be flipped around, so it's kind of like reciprocal. 1 over x to the, now it's not negative 5, it's positive 5. So these two things actually mean the same thing. When we do problems and we get negative exponents, we do not keep our answer as a negative exponent. You never have negative exponents as your answer. You need to simplify them and put it down the bottom. So think about flipping it around. So we're going to try an example. So what if we have x to the negative 2 over x to the 5th? Well, before trying to flip stuff around, why don't we do the property that we know we can do, which is subtract these two, right? This would mean you're actually doing, because you have division here, that means you do negative 2 minus 5. That would be negative 7. All right, so when this happens, you write it like this. Subtract them, it'd be x to the negative 7 on top, and there's nothing on the bottom now. So how do we fix this? We flip this around, make it 1 over x to the positive 7, and that's your answer. And they do get, a lot more complicated than this, but this is just kind of the baby steps. Let's go down and do part D. What happens whenever you have a power raised to another power? In this case, you do multiplication between the two to get the answer. So this would be r to the negative 5 times negative 2 is positive 10. So in this case, we don't have to flip anything around. We simplified it first, and we're done. I think I'm going to save kind of like B probably for last. All right, how about E? K to the 5th over K to the 10th. Since you have division, we subtract. So this would be like 5 minus 10, right? So off the side, you can think about what's 5 minus 10? That would be negative 5. So that's kind of ugly. So this means we have K to the negative 5th power over 1. And again, we have to flip them around. So it's 1 over K to the positive 5 as your final answer. All right, let's go to, how about we do C, which is very similar to part D. We have negative 4 as an exponent. It's also being raised to the 6th power. So we have a power to another power. So if you remember, power to a power, you multiply the exponents. So what's negative 4 times 6? That's going to be negative 24. So it's p to the negative 24th power. And then we're going to flip this around like it did up here, put this over 1, and flip her. So it becomes 1 over p to the 24th power. And that's your final answer. All right, how about F? We have y to the negative 3rd times y to the negative 9th. So let's put them together if we can first, and then we'll deal with the negative. So you have negative 3 and negative 9. So when they're separate like this is like the very first kind we did. If I go all the way back, what was it? Like these ones here. If they're separate like this, when you're multiplying the variables together, you have to add the exponents. This is the addition one. So we have to add these two together. So what's negative 3 plus negative 9? Still going to be negative. It is negative 12. And since we have a negative answer, we can't keep it that way. Put it over 1, flip her around. So it's 1 over y to the 12th. And it's done. All right, B I think is the most complicated one, so we'll see what happens here. Let's see. I think I'm going to do something a little different this time, just to show you a different way of doing this. So if you don't like the negative exponent here, we're gonna kind of ignore this just for right now. This is being multiplied together, but let's just ignore it for right now. What you can do to make this positive right away is you can put this whole thing, whatever's in parentheses here, over 1. And we can flip this right now, and then we can deal with this 2e a little bit later. So let's flip this around, and that will make this become 9e to the positive 2nd power. So let's do it that way. So let's flip this around. We're going to have 1 on top, 9e, and now that is to the 2nd power. We still have this 2e on top with parentheses, but we can put that over 1. But I'm not going to deal with that just right now. Okay, and then what we need to do is, since we have a power to a power, this is e to the 1st. We need to multiply these exponents, and then 9 also gets the exponent. So let's write this out. We have 2e times, and we have 1 over 9 to the 2nd power is 81. And then we have 1 times 2, because power to power here, it's e squared. I think I might finish it down here, actually. So how do we put these two together? Well, we could just keep the top 2e. The bottom would be 81e squared. I'm going to mark it as one fraction. You can multiply across the top. 2e times 1 is 2e. The bottom is 1 times 81e squared. So this is where we're at. Now, if you look at the numbers, 2 and 81, they cannot be simplified any further without getting a decimal. But I'm not going to try to get a decimal. But what we can do is we can do subtraction with the e's. So we can do 1 minus 2. So let's put this answer down here. We still have 2. We still have 81. 1 minus 2 is negative 1. So that means we get e to the negative 1. And so how do we change this? We have to put this on the bottom. Now, the bottom here is 81. We don't have to mess with this. We just need to move this to the bottom, right? Because normally this would be over 1. You can flip it around. We don't have to mess with the 2 and 81. We can just put that on the bottom. So it'd be 2 over 81, and now it's e to the first power. So you don't always have to write it over 1 and flip it. What you're really doing is you're just moving it down to the bottom, like you did in these examples here. So here, and then here as well. And that would be your final answer. They do get, a lot more complicated than that. So you're going to finish up the rest of this and see how well you do with that, and then we can kind of go over the problems later, because these get a little bit more complicated when you get further in. So like this last couple of problems here, they're a lot more difficult, way more difficult. So try the rest of the huddles and make sure you do the mastery and the warm-up as well. So we can talk about the rest of that on the next day you're in school.